Imagine a world where security is seamlessly integrated into your development workflow from ideation until the very production, so that the development team can completely focus on the feature development while developing secure application. Does this sound like a dream? I don't think so. Let's come with me. So this presentation here is a presentation that I have done on the 19th of February in the OWASP chapter Meetup Switzerland. And the title, as you can see, is Continuous Security with DevSecOps, How Platform Engineering Transform Modern Application Security. Let's dive into this presentation. First, to myself, my name is Romano Ross and I am the Chief of DevOps and a partner at Zülke. I work for Zülke now since 23 years, joined Zülke directly after university as a junior .NET engineer, became then an expert software engineer, then an architect, and finally a consultant. And one thing that was always at my heart is how can we continuously deliver value? How can we automate things? And how can we ensure the quality and the security of what we are building? And when the whole DevSecOps movement started, I jumped right on top of that, became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup. It's always free to join. And I'm also one of the organizers of the DevOps Days Zurich, which is a yearly conference. The next one will be in March, but unfortunately it's already completely sold out. These DevOps days, they are all around the world in all of the big cities around the world, and I am the president of the DevOps Days Zurich. Now you can see DevOps lies very close to my heart. This is also why I have my own YouTube channel with over 250 videos on it. I also tweet a lot, I post a lot on LinkedIn, so if you want to learn more about DevOps, you can always join me. I'm also currently writing my own book about that topic, and I'm also a lecturer at HSLU about digital transformation, about enterprise architecture, and obviously DevOps. In my projects, I work with different clients in different industries doing DevOps transformation, platform engineering, and also architecture assessments. Currently, I'm working for LGT as a product manager of a platform that we have jointly built together with them. And this platform will, of course, also be part of this video to showcase you how DevSecOps can be built into a platform and to showcase also what the benefits of that is. So let's have a look at today's challenges. When I join different companies, then I see a picture like this. We have in the middle the business. They have absolutely bright ideas. They put these bright ideas into Jira documents and Word documents, and then they throw it over the wall of confusion to the development team. The development team looks at that and says, if you want to have that, we can implement that, and they implement something. And then they throw it over the wall of confusion to the test team. And the test team looks at that, looks at the specification, it's not the same. They test something, it's green, and they throw it over the wall of confusion to the operation team. And the operation team says, whoa, how should we operate that? This will never work in production. But with a lot of duct tape, they get it to work and it gets shipped to the business or to the customer, and they say, what is that? We cannot use it. And this is, in some extent, something you see in many companies, even if they say they are doing DevSecOps. Because what you can see here in blue is the value stream, but the value stream is broken by these walls of confusion, and these walls of confusion are coming from the silo organization that we see still, even if they are doing DevSecOps in many companies. These silos, they usually are business units. So we have a business unit for business, we have a business unit for the engineering, one for QA, and one for operation in that case. And this is also something you see in many enterprises still nowadays. So the problem with these silos is that they have not the same goal, and this leads to a misalignment. Also, what you usually see that you have legacy applications, legacy application landscape, legacy processes in place, and usually security and also quality is something that you are doing when you are already in production. Also, regulatory and compliance are also challenges in such a setup. So when we look at that and when we look at DevSecOps, then DevSecOps is here to help, because DevSecOps is a mindset, a culture, and a set of technical practices which helps us align across that value stream, bring all the people together so that they can work together on a product. So this is what DevSecOps is. And when we look at that term DevSecOps, then we need to go back to the initial term, which is DevOps. DevOps says development and operation. And of course, there were some smart people out there which said, nowadays security is very important. And therefore, we called it DevSecOps, which is development, security, and operation. Another bunch of people are saying, no, we should call that BizDevOps, which is business, development, and operation. And you can see this whole discussion about the terminology is leaving, or it's leading nowhere, because what we would need is a term like DevSec, Bits, ArcComp, QA, Ops, and I'm pretty sure I have forgotten someone. We can also call it DevStarOps or DevXOps, or we just call it DevOps, because DevOps or DevSecOps is all about bringing all the people, the process, and the technology together to continuously deliver secure value. This is what DevSecOps is. Now, when we look at the benefits of DevSecOps, then there are tons of studies out there. The State of DevOps report 2024 is out, and they are comparing the high performers, those who are doing DevSecOps, versus the low performers, which are not doing DevOps. And you can see the numbers are very impressive. Those companies which are doing DevSecOps have 182 times more deployments. They have a 127 faster lead time, and so on. When you boil that all down, you can clearly see that with DevSecOps, you have a faster time to market, more value for money, higher security, higher quality, higher customer satisfaction, and top qualified employees. And this is exactly what the CIO and also the CEO of a company wants. So, all good. Why is not everyone doing DevSecOps then? So, when we look at the internet, then we see pictures like this, that DevSecOps is bullshit, and that the new kid on the block is platform engineering, and that DevSecOps is already dead and we should bury it. What is the problem with DevSecOps? Now, as I said, DevSecOps is a culture, a mindset, and a set of technical practices. And here is the set of technical practices which you should apply when you want to do modern software development. And yes, that's quite a lot to do. Now, when we only look at the CI/CD pipeline, so the continuous integration, continuous delivery or deployment pipeline, then you can see from that picture here that when you want to bake in only the security part, this is quite a lot. Here we see on the first line GitHub and on the second line GitLab, and also how you can bring in security only in your CI/CD pipeline. Paddy Steger and I even created 25 videos, 12 videos for GitLab and 12 videos for GitHub, only on how to implement DevSecOps in your CI/CD pipeline. The 25th video is then about the summary of all of that, and you find all of these videos on my YouTube channel. So you can see only that is already quite a lot. And you know that when we are doing DevSecOps, our battle cry is you build it, you run it, which means we need to have infrastructure, cloud or on-prem. We need to have a runtime, Docker, Kubernetes, a virtual machine, a CI/CD pipeline, GitLab or GitHub. We need to have a monitoring with Prometheus, Dynatrace, security with Snyk, SonarQube, and so on. We need to have tools like Jira, Confluence. We need to do a cost management of all of that, especially when we are in the cloud. We need to maintain these tools, so keep them up to date so that they can integrate with each other. And we, of course, also need to provide access and identity. Oh, and I completely forgot. We also want to develop features for an application. So that's quite a lot to do for a development team. Now imagine that in a bigger company, then you can see that the cognitive load gets quite high because you have multiple of these application stacks potentially in place. And also the complexity of these tools will be very high. So this is not very good. This leads us to the question, can you scale DevSecOps at all? Is that possible? Or should we go back to the silo organization, back to separation of development, security, quality, and operation in separated silos, so that we don't have this complexity anymore? Let's take a step back and see what companies really want and where the industry is moving nowadays. I brought you a picture, so sort of a mind picture. So how companies are developing products in the future and where the whole industry is moving. In this picture, I use drones. You can just replace in your head drones with your own application. I use here only drones because it's better to draw drone than an application, and it makes it a little bit more engaging and fun, this example. So here we have a company. They are creating small drones. They have a small market share, and their vision is to increase their market share. And how they want to do that is they want to build other drones, a maintenance drone or a drone which can do heavy lifting. So on that level, you are on the board level, where these board members look at, they have a vision, they have a strategy, and they look at how they can achieve the strategy, and they decide on that portfolio level that the right strategy would be to build a drone which does some heavy lifting. They give this idea down to the product level, where the product managers are, and the product managers take that and look at what kind of drone do we need to build? What are the features that this drone needs to have? And they say in that case that this drone needs to have a bigger battery, and it needs to have a bigger motor, and they give again these features down to the team level. On the team level, you have already 2 teams working on this small drone. You have one team that is developing the software and one team which is developing, in that case, the battery. And you can also see they have a fully automated CI/CD pipeline with, of course, security directly built in. Now, for that new drone, we need to have a new motor. So therefore, we need to have a new team. So here, platform engineering comes into play, and they are giving this team a standardized, already secured, automated CI/CD pipeline so that they can start in no time with the development of their application. So everything will be assembled together, it goes to the customer, but with that the story does not end, because now we need to continuously monitor these drones and give back this telemetry data to the team so that they can continuously improve their parts. But also with that, it doesn't end. Now the data flows also back to the board level, because the board level has a vision. They want to increase the market share. Now we need to give them the data about customer satisfaction, about our market share, so that they can do the right decision whether they want to invest more into that drone, or if they want to pivot and perhaps also develop another drone. This is a very important thing to do, and this whole concept is not a new concept. It's called the digital factory, where we have on top the lean portfolio management, which aligns the strategy with the execution. You have the product management, which organizes the different products and teams. You have the product teams, which are doing DevSecOps and building parts of the whole solution, or the solution itself. And you have the platform team, which is the foundation, which builds the platform where the product teams build their software on top of that. Now, let's have a closer look to that new kid on the block, this platform engineering. So when we look at platform engineering, then usually we say platform engineering is the industrialization of software engineering. And I show you why this is the case. So in many companies nowadays, you have product teams which are completely internal. You have product teams which are external, which deliver software to you, which is potentially also bought, and it's a standard product. And then you even have mixed teams where, for example, you have internal developers and also external developers from consultancies which help you develop products. Now, the challenge with that is they all use different development environments, and also how they deliver these software is usually also quite different. Which leads you with a quite large software landscape that is in use. Now, where the industry is moving is into the direction of building a platform where you standardize how software is built and delivered, which means you have a standard set of services and products that are used. So that's why we talk about the industrialization of software engineering. Now, let's have a look at the target operating model of platform engineering. So in the past, the teams were quite large and they had all of the roles in it to deliver software, which also led to a large technology stack and to a quite large cognitive load. Where we are moving nowadays is that we have product teams which focus on the feature development, while on the bottom you have a self-service platform which is built by a platform team. And you can see now the technology stack is split up. Let's have an even closer look at this platform engineering. So we have a platform team that builds this platform, your platform. And this platform is an internal product, and this is important to understand. It is an internal product, and the consumer of this, the customer of this product are the product teams. They are using this platform. You can see that this platform exposes all of the tools that these product teams need. It also has all the capabilities that these product teams need to build their products. The product teams, they are doing DevSecOps. They have the end-to-end responsibility about their product. So now the important thing comes. When we look at the capability observability, the platform team over the self-service platform exposes the capability of observability, like with monitoring tools, default dashboards, tools like Dynatrace or Grafana are in there, where they expose in a standardized way that to the product team. So the product teams can now consume this capability, these tools, and use these tools. The important thing is the monitoring is done by the product team, not by the platform team. So therefore, the platform team generates value for the teams in form of an internal product, which is a self-service platform. And the product teams, they are generating value for the customer. That's the important thing about how platform engineering works. Now, how does that work in, for example, a bank? Here in the example of LGT, how we have implemented that together with LGT. So when we look at this picture, then let's have a look at that. Then you can see that you have the cloud part, which is over there, and you have the on-prem part. Then we split it up in development and into production. Now, in the cloud part, the external developers and the internal developers are working on a developer platform. So there, the different applications are developed with, of course, API mocks and with synthetic test data. The important thing is the same platform is then used in the production cloud and also on-prem. So part of the applications run in the production cloud and part of the application run in on-prem on the same platform. This ensures that we always have the same configuration, the same tools, the same policies in place. And this is quite an interesting approach. So, for example, when you look at that, then you can see that the platform, the production platform, grabs into the development cloud and gets the artifacts, and then these artifacts are deployed into the production cloud. So when we look at that, how does that look like in practice? So here we can see a high-level architecture picture of such a platform. You can also take that sort of as a blueprint, but that's also how we architected the platform. On the top layer, you have the different roles. They are using the platform over the CLI or over the portal, and they are using directly the tools. So the platform should never hide away any of the tools. It should expose them, but over the platform. The interesting thing is you see then down there a layer, the internal developer portal. Usually people refer to that as backstage, for example, but this is only half of the story. So in our case, we also have that internal developer portal, and of course we did domain-driven design. We said, okay, what are the domains of such a developer platform? It's repository, artifacts, packages, and so on. But then the hard work comes, because what you want to do is you want to automate as many things as possible. As I said, such a portal should be a self-service portal, and therefore what you want to do is you want to have an automation block, and you want to integrate all of these applications. And here again, a very important thing is you don't want to integrate the tools like that together. You always want to integrate them over the platform. And again, how do you do that? With architecture, you define adapters and connectors for each one of these tools, and then you have some unified integration blocks for each one of them. For example, for a repository, you have a unified integration block, and down there you have an adapter for GitLab and one for GitHub. And in the future, you potentially also have one for Azure DevOps or Bitbucket and so on. And that's an important architecture approach, because you never know when one of these tools needs to be replaced by another tool. Now, this whole architecture that you can see here, or this concept, is from Gregor Hoppe. He has written an absolutely amazing book about platform strategy, and he calls that concept a floating platform, which means your platform floats on top of all of the tools, DevOps platforms and also cloud platforms, and you just integrate these platforms into your platform, which is then a floating platform. You never duplicate any of the features, and you also don't hide away the tools from the people. You just integrate it into it. So this is the concept of the floating platform. Now, another very important thing about platform is that with a platform, you are able to codify all of the guidelines and rules and policies. And this is in the DevSecOps space very important. And this is also my advice to you. Don't write these policies into Word documents or into Confluence pages. Codify that over the platform, because with that, no developer needs to read these rules, these guidelines. They are just automatically applied, and with that you give the development team a great advantage and also a great speed. So now I have talked about platforms for quite a long, and I didn't mention until now AI, and usually AI is the biggest topic out there. Now, the question is, where is AI in that picture? Let's have a look. So when we look at platform engineering, then in the platform, AI is just a capability. Over the platform, you expose AI as a capability to the platform, to the product teams. So it's capability, you expose that over an API to your product teams. That's the important thing. Now, some of you will say, but Romano, this box is quite tiny. AI is such a big topic. Now, let's zoom in into that. When we zoom in, then you can see that this box is quite huge if you want to integrate that properly into your platform and have AI used in a governed and standardized way. So on top, we have the developer portal with the CLI and the APIs, and then we have a whole layer about application where we expose applications like chatbots, synthetic data tools, or AI coding assistants over that. Then we have a layer about tools where we have prompt engineering, vector database, RAG, fine-tuning tools, and model lifecycle management with DataOps, MLOps, and ModelOps. And on the bottom, you have all of the models. You want to have a model hub for your models where you can version them. And on the bottom, you then have the Gen AI infrastructure where you plug in the potential cloud interfaces, so interfaces to OpenAI, and of course also to potential on-prem infrastructure that you have. Now, enough of the talking. Let's have a quick demo about that platform that we have built together with LGT to showcase you how you can build in DevSecOps into such a platform. Now here we are on that platform, and of course we have also a dark mode for our developers, but for presenting that I will stick to the light mode. So here we are now on the first screen. Some of the projects that we are currently working on are of course grayed out, so this is not an error of your graphic card. This is by intention because there are of course some customer names on it. So what you see here is the platform that we use at Zülke. As I said, we developed that platform together with LGT in a joint investment, and therefore we use that platform internally for developing our projects with our customers. So if a customer does not have such a platform, then we can develop it on that platform. And of course, we are using that platform also as an accelerator asset for our customers. So if they want to develop their own platform, we can use either the concepts that we have in there or even the whole platform as you see it here for our customers. LGT has their own instance. In fact, they have now 3 instances, one for their developer cloud, one for production, and one for on-prem. So I will go quickly to the administration area. Here we can see that currently 462 developers are working on our platform with 14 partners, 22 spaces, and 15 Kubernetes cluster. And you can also see a view on FinOps, so how much this platform costs us each month, again blurred out. One of the important features, as I mentioned, is the partner feature. LGT and of course also Zülke has different partners. So in the case of Zülke, we work with customers. So if a customer comes to us, then he will be onboarded to this platform. We use here bring your own identity with Azure Entra ID, and then he or she has access to the platform. Now here is the important thing. As I said, this platform is a floating platform and we integrate all of the tools, which means that in that very moment when we onboard someone, he or she has access to all of the tools and also to the repository where she has the right to access. Now, which also means in that very second someone is onboarded, and we can also offboard, for example, in the evening someone. This usually is in many companies not possible. Usually this takes weeks until you really have access to everything you need to have. And this alone is a very important feature in my opinion. Also, it's completely self-service, which means we assign someone as the owner as the partner owner, and this person then can onboard or offboard the people by themselves. The second important concept is the space concept. A space is nothing else than a networked zone. What the team does in that zone, we don't care. They can have a Kubernetes cluster in there. They can have virtual machines in there. It's completely up to them to do whatever they want. If they want to have multiple projects or product in there, it's completely with them, or if they want to have multiple of these spaces. Now, talking exactly about these spaces, we have here the platform space. So the platform plane, as you can see here, is developed in the platform plane. We can go to the repositories. As I said, one of the domains is the repository domain. Here we can create new repositories also with templates where we can select if we want to have it in GitLab or in GitHub. This is something we can do, and when we click on one of these repositories, we are of course directly signed in via single sign-on. And again, this is of course important, and it's also part of DevSecOps, where we have that identity and access management solved for the whole development. Also, credentials, you don't need any credentials. If you would need credentials, you can get it from the platform. All credentials are stored in our case, in a HashiCorp Vault. But again, here it's just an adapter for where you want to store your credentials. Another important thing is this one here. Here, because we have now all of the repositories under one platform, we can of course also scan them. And here we are doing a scan with Trivy of this repository where we do a static code analysis and also scan for secrets. We also do secret detection. We then can go to repositories. Here the containers are stored. Of course, we also have a package store. In there is at the moment nothing, because the platform plane relies heavily on containers. But if you have legacy applications with Maven, NuGet or NPM packages, they would be stored in there. And again, here we can see now this container image Argo CD operator. We also see here the different version numbers. I can also click on one of them, then I see the container scanning results. Oops. The container scanning results. We would also see here the violations, and we also see here the layering of that container, and we can also analyze this Docker image with an AI. And here comes the interesting thing. Now, when you have such a platform and you integrate everything together, you have that concept of a floating platform, then it's just like playing Legos, because you have the APIs and you can just sort of create new stuff out of it. In that case, we said, hey, wouldn't it be great to, because we have the container image, to just use the interface to AI and scan and go through the container images and give the developers some tips and tricks about their container image. And they like it quite a lot. Another important feature is the so-called provenance feature, where we can have a look at who has made that change. For example, here you can see, for example, where was it? Potentially we want to identify who has introduced some vulnerabilities, and then we see that in that case. And then to the platform itself. Here we see the Kubernetes cluster itself. As I said, we can of course also create virtual machines, which we don't have here, but you could create here virtual machine in a very standardized way. So without going to the Azure portal and doing that sort of manually, it's completely automated, and you can have them of course also as a deployment target. Here in that case we use Argo CD for deploying to the Kubernetes cluster, and we again see here for example the chat application which we use at Zülke. This is our chat which we use in a governed way. We see the Kubernetes objects down here, again application violation and application vulnerabilities here, and we can also have a look at the log files. And this is also now very interesting because I'm directly logged into Grafana here, where we have also the possibility to use Tempo directly, so that we get this nice service graph, which is the microservices of our application. We also can click here on to the dashboards, where we then also have the default dashboards in place. As a developer, when I create something, all of that infrastructure is right there. So when I create a new space, deploy my container into it, everything is there. I just need to log out to standard out, and everything will be picked up. We also can analyze here the log files again with an AI. As I said, having such a platform is just like playing Lego. We have on top of here the service catalog, and bear with me, it's not ClickOps. Of course, you can choose here, for example, Azure OpenAI or MySQL SQL database, which creates you that database, but down here you can have that template as infrastructure as code, and that would always also be my recommendation, to put that into code and use GitOps to create the resources. But if you want, you could of course also create it directly from here. And again here the important thing is you offer them, the developers, a standard set of tools and services in a standardized way. And again, back here, all of the DevSecOps rules, policies are of course codified in the background for each one of these services that developers can consume. With that, to the last part of that demo, this is the newest part which we have. This is the so-called release portal, where we can create releases for our softwares that we are creating. So you remember, we have one platform from ideation until production. We use the same platform, which means we have two instances, and with that a developer can create a release, which then is picked up by the productive platform. It's grabbed, it grabs all of the resources and displays that inside of the bank in the productive cloud or on the on-prem environment. and then a release manager can approve that. You can also see here that we are pointing out the vulnerabilities that we are having, and if there is a critical vulnerability, you are not allowed to deploy that inside of the bank. And then the last thing which you can see here is the costs that this space has, and also the CO2 consumption, and you can also add here people and roles. So this was a short demo of the platform and how we integrate DevSecOps into such a platform, which is also my recommendation. If you want to do DevSecOps, integrate it into your platform so that you can support your development team. So when we look at that, then we can clearly see that the IT is moving away from that IT where you just had quite a lot of services which you then need to pick up and configure by yourself with some rules and guidelines, where you create a ticket and then wait for days or weeks so that you get that service. And still, when you get it, you need to do quite a lot of things manually by yourself. Where the industry is moving is to a factory, an enabling IT, how we call it, where you get pre-configured services or whole products, where you even can get a whole development factory for yourself, where you can build standardized your application. So this is where the IT is moving into the direction of an enabling IT. So to sum that up, DevSecOps is absolutely not dead. And everyone who is saying that usually out of a purpose, because, for example, he or she wants to point you to, for example, platform engineering. Of course, platform engineering is the new kid on the block, but platform engineering enables the teams to do DevSecOps, and that's the important thing. Which means that you need to build your own platform. A platform is an internal product. It is your self-service portal. The customer of that self-service portal is the development team. This is also why it's an internal product, where you need a product owner. And also important here is that you are going to codify all of the DevSecOps rules right into the platform, so that you standardize how to do DevSecOps in your company. So with that, you can clearly see that we are entering the age of industrialization of software development. Platform engineering builds your platform, which is the foundation of your digital factory, and enables your teams to do DevSecOps. And this is the way how we build secure applications. Thank you very much.